Hello students, in this module we have to learn about machine learning types. So let's have take a look about what are the learning objectives. Basically in this module we can start from the supervised learning, then we have to see about different type of supervised learning types, and then particular from the supervised learning we have to talk about classification and regression. After that session, we have to discuss about what are the importance and what are the logic behind the linear regression and the logistic regression. So from this module, the two key concepts are the linear regression and logistic regression. After discussing about linear regression and logistic regression, we can move forward to the unsupervised learning. From the unsupervised learning, we have taken a little bit introduction about k-means clustering. So let's start with the first part based upon a supervised learning. And from the supervised learning, we have to discuss about supervised learning case study. Ever wondered how Amazon make recommendation? Amazon divides or the devise an algorithm that begin looking at items themselves. It scopes recommendations through the user's purchased or rated item and paired item to similar items. Using metrics and composing a list of recommendations, that algorithm is called item-based collaborative filtering. The recommendation system that is the main part of the machine learning, and that's why with the machine learning it will consider as a supervised learning. Amazon uses a supervised learning algorithm to predict what item the user may like based upon the purchase history of similar classes of users. If from your Flipkart account or the Amazon account, if you in your past history, if you can search related to some computer systems, so after some time, also Amazon and Flipkart, based upon their recommendation system, they will recommend to you like pen drive or mouse or keyboard type of accessories based upon a computer. So that's how supervised learning with the recommendation system should be worked. So let's check it out. What is the meaning behind the supervised learning in terms of definition in proper way? Supervised learning is a type of machine learning used to learn models from labeled training data, and it allows us to predict output for future or unseen data. In other words, supervised learning is the machine learning task of learning a function that maps an input to an output based on input output pairs, and it infers a function from labeled training data consisting of a set of training examples. The great examples of supervised learning is a text classification problem, and in this set of problem, the goal is to predict the class label of a given piece of text. One particularly popular topic in this text classification is to predict the sentiment of a piece of text like a Twitter or a product review. So that's how supervised learning will should work. Now we have to look about some more example based upon a supervised learning. And among that, the first example is based upon a voice assistant. Voice assistant like Apple Siri, Amazon Alexa, Microsoft Cortana, and Google Assistant are trained to understand human speech and intent. Based on human interaction, this chatbot take appropriate actions. Let's talk about the example number two. Second example is based upon a Gmail filters. Gmail filters a new email into inbox like a normal or a junk folder. It is called as a spam based on past information about what you consider as a spam. Sometimes some companies are sharing some mail with you. You can consider that mail as a spam. But if your colleague will share on any type of the mail, that you consider as a not spam or the normal spam, normal thing. It's not spam like that. So it will come in a inbox. Let's talk about the third example, that is the weather apps. The prediction made by weather apps at a given time are based on some prior knowledge and analysis of how the weather has been over a period of time for a particular place. So we all are using the weather application in our smartphone. So we are getting an idea like how accurate weather application are working based upon a prediction of machine learning or prediction regarding to the supervised learning. Till now related to the supervised learning, we already getting lots of idea. Now let talk about something based upon a types of supervised learning. So basically two type of things are over here. First is the classification, and second one is the regression. In this part, first of all, we have to discuss about or the meaning behind the what is classification. Classification is a type of supervised learning, and it specifies the class to which data elements belong to. It is best used when the output has finite and discrete values. It predicts a class of an input variable. There are two types of classification are there: binomial or the binary, and the multi-class classification. In machine learning, classification refers to a predictive modeling problem where a class label is predicted for a given example of input data. For example of classification problem include given example like classify the mail is spam or not spam, given or what are the handwriting character is there, that the handwritten or the printed are there. Also, we have to classify it as one of the known character or not. So here, if you can see in this diagram, there is some type of spaces are there, like dog spaces are there, genesis are there, families is there, then order is there, class is there. So we are getting different type of animal according to that one, like who are the kingdom, like oh, total animals are there, like how it should relate it, like there is different type of animal classes are there, though some animal are flying in air, some animal will walking in a land, and some animal are do swim in water. So that type of thing is there. Okay, so after a discussion about the classification or the meaning behind the classification, let's little bit go with the some machine learning language type of stuff with the classification, like what class, like according to the classification, what class applied when the output has finite and discrete values. Example like social media sentiment analysis has three potential outcomes, like positive, negative, or neutral. In machine learning, classification refers a predictive modeling problem where a class's label is predicted for a given example of input data. So that's how we are getting some more idea. Like here we are having some binary chart is there or binary graph is there. So the green sample is represent like mail are not spam, and the red crosses are represent like mail is spam. So according to that one, we have to create one line. According to that line, we are getting an idea which are the plus one and which are the minus one thing are there. So let's talk about some example in deep with the classification example. Social media sentiment analysis has two potential outcome, like positive or negative. So whenever you are getting some on a Twitter or on a Facebook or an Instagram, if you are getting some positive comments like the peak was good or peak was nice and peak was not good or whatever the comment is there, comments are also coming in positive way, as well as comments is also coming in a negative way as well. So that's how we can get some better idea like what are the positive comments and what are the negative comments. So that we have to classify throughout this boundary line. So boundary line is represent with the classification. So this is type of the classification for working for the binary classification. But whenever we are having some four classes are there or five fifth classes is there, so we can consider as a multi-class classification. So after discussing based upon this one, like we can also take in some iris classification. So iris is the one type of flower is there, and the flower will consider within three classes, like 0, 1, and 2 is there. So there's different type of classes are there, like virginica is there, satosica is there, imagica is there. So that type of thing are working over there. And the test set dots represent the assignment of new data points to one class or the other based on the trained classifier model. So that's how thing was working in a classifications. After getting basic idea about the classification, let's talk about some of the thing based upon a regression. Classification are working with some discrete values, like within discrete class, like 0, 1, 2, 3, like that, to based upon their classes. But regression should work within some continuous parameter. Okay, so applied when like answer is again how much, and applied when the output is continuous number. So a simple linear regression algorithm, it's a y is equals to wx plus b in terms of example, like the relation between the environmental temperature and the humidity level. Okay, so because we have to predict the weather, so that's why environmental temperature and humidity level, it's both are required. So based on the value of one or multiple predictor variables, briefly the goal of the regression model is to build a mathematical equation that defines y as a function of x variable. So based upon y, we are trying to define x like that one. Okay. So because here the x is the independent parameter and y is the dependent parameter, and y depends upon the x. Okay. So always x is defined but y is not defined. We have to find x based upon a, sorry, we have to find y based upon the x. Okay, so that's how the thing is there. Just in this session we are just getting basic idea about the how supervised learning should work and what are the types, and in that types what are the basic meaning behind the classification and regression. From the next session we have to take some deep dive within what is the regression, and we can see some real world application based upon a linear regression. And in that linear regression we can also evaluate the how mathematics behind the linear regression should work over there. In this session, we have to learn about what is regression. Also, we have to find out the types of regression, and from the linear regression, we can see about how linear regression should work and what are the mathematical representation behind the linear regression. So let's start it with the what is regression. Regression is a statistical method used in finance, investing, and other disciplines that attempts to determine the strength and character of relationship between one independent variable and a series of other variables. In statistical modeling, regression analysis is a set of statistical process for estimating the relationship among the variables. So here we have to define the relationship between x and y. X will be stand as an independent parameter and Y will be stand as a dependent parameter. Always Y is depends upon X. So we are whenever we are trying to do some project or coding, so X is already defined, and from the X we have to define Y. So after understanding of what is regression, now let's talk about the type of regression. So the basic and first type of regression, that is linear regression. The second type, that is a multiple linear regression. So once you can learn about the linear regression, then it is very easy to learn about the multiple linear regression, because the inside method and mathematics are similar for the linear regression and multiple linear regression. Just the difference is that whenever we can talk about a linear regression or a simple linear regression, at the same time we are only taking one independent parameter and one dependent parameter. But whenever we have to talk about the multiple linear regression, so at the same time we are able to take lots of independent parameter and one dependent parameter. So lots of x are there and just only one y is there. After third thing or third type, that is the polynomial regression, and the fourth one, that is the decision tree regression. So let's start it with the linear regression thing. So linear regression is a linear approach for modeling the relationship between scalar dependent variable y and independent variable x. So that's how it should work in a linear regression, like relationship between x and y. So here if you can see in this equation, like y hat is equals to w transpose into x. So x will stand for the input and y will stand for the uh, dependent parameter. But what is the meaning behind the w transpose? Okay, so this is the standard equation is there, but first of all, before going to standard equation, we can derive or we can get some basic idea about like 12 standard signs, like y is equals to mx plus c. I hope everyone will know about the y is equals to mx plus c. Okay, we can discuss about that one, but still we can talk about some basic thing related to the linear regression. Linear regression is the next step after the correlation. So whenever we are trying any type of the project, or we can find out how to apply the correlation matrix and how to check it out correlation matrix, or how to find out some basic things related to that, then we can go with the linear regression. It is used when we want to predict the value of a variable based on a value of another variable, and the variable we want to predict is called the dependent variable, or sometimes the outcome variable. Simple linear regression is used for finding the relationship between the dependent variable y and independent variable or the predicted variable. Both of these variables are continuous in nature while performing the simple linear regression. We assume that the value of predictor variable x are controlled. Furthermore, they are not subject to measurement error from which the corresponding value of y is observed. The equation of a simple linear regression model to calculate the value of the dependent variable y is based upon the predictor variable x. So again, we have to find out the things between x and y. So again, come over here from the y hat w transpose x. So where x, y, where the vector of real numbers and w is a vector of weight parameter. So the equation is also written as y is equals to wx plus b, where b is the bias or the value of output for a zero input, and x will play as a input, and w is the weight parameter is there. Let's see some real world application based upon a linear regression. Like based upon linear regression, what are the real world application we can explore? So the first application is based upon a weather prediction application. The goal of multiple linear regression is model to relationship between the explanatory and response variable. And it was found that the proposed model is capable of forecasting the weather condition for a particular station using the data collected locally. In weather application, we have to apply multiple linear regression because we have to apply multiple inputs. So after linear regression, we can talk about the multiple linear regression, and that multiple linear regression we are easily applied in real world regression examples. Second application is based upon a housing price prediction. So prediction of housing price using the regression algorithm for machine learning. It's a machine learning has been used for years to offer image recognition, palm detection, natural speech comprehension, product recommendation, and medical diagnosis. So lots of applications are based upon a machine learning. But whenever we talk about the housing price prediction, so at the same time, nowadays like many applications are available like housing.com, then broker.com, and many applications are available if you want to find out the what are the correct price of the house according to their locality, what are the facilities available according to their house. So nowadays lots of websites are available to prediction of this one, so that's why based upon that we are getting an idea like housing price prediction as well as the next application is based upon like employee salary prediction. So what type of thing we can getting from the employee salary prediction? In the employee salary prediction, according to the employee performance from the few of years like 5 years or 7 years, we are getting an idea how much increment should become in employee salaries. So how much of growth employee can get from over the years, what are the level of work is given by the employee. So that type of thing we can get over there. So basically mainly thing is based upon employee experience and employee classification. So that's how we can get an idea like how employee salaries prediction should help to predict with the machine learning or the linear regression. And the last real world application, if we take like there is a Virat Kohli run prediction. So based upon a Virat Kohli current performance, stadium experience, performance against the opponents or current year performance, current year numbers. So based upon many type of stuff are working over here, and based upon that we are getting an idea like how much run today Virat Kohli will made in this particular ground or in this particular match. So that type of thing are there. So basically we have seen about the four real world application based upon a linear regression. So after getting about this, now it's time to go with the some mathematics based upon a linear regression. So let's start it with the mathematics thing based upon a housing price prediction. In this table, there is two column is present. One is area and second is price in INR. When the area was increased proportionally, prices also increased. But at the one level, only area will increase and suddenly price will decrease. But these things it's come due to the threshold. Let's put all the sample in this graph. So here y is dependent variable. It is also known as criterion variable or the regression. Whereas x is known as the independent variable. It's also known as the predictor variable and the regressors are there. So once all samples are plotted in this graph, then you will get an idea related to the linear relationship, like how area will increase and price will also increase. So, but now we have to see some more additional thing based upon this one. Like now, based upon this one, like if I assume like 10,000 square feet meter is there, area is equals to 10,000 square feet meter, and according to that sample value is around 1 crore in INR, but according to the linear relation price is just only 60 lakhs. So based upon that, we are getting difference around 40 lakhs. And in machine learning language, it is called as the difference between actual output and predicted output. It's known as mean square error or particular type of the error. So here, once here it's the actual output and 60 lakhs is the predicted output. So 40 lakhs are become an error. So here if you can see y and y hat is there. Okay. So we have to find out difference between y and y hat, and what are the difference we are getting in between y and y hat. It's become a mean square error in terms of it is difference between actual output and predicted output, because actual output is like whenever the 10,000 square feet meter is there, according to the actual output is I think 1 crore. But whenever we have to talk about like linear relationship and the linear regression, so this green line will draw come from the linear relationship, and that linear relationship will just only represent the value 60 lakhs. So here we are getting an error. So this type of problem we are trying to solve during this linear regression, and that is the again important part is comes over here. So let's do one small activity based upon the same topic of variable affecting upon a regression techniques. Here we can see some equation, but we already discussed about this equation. Like our ultimate goal is minimize y minus y at its difference between, like what are the error we are getting over here, like MSE. We have tried to reduce that one. So let's see this activity. If we apply the value of m and c in this equation of y is equals to mx plus c, so at the same time we are getting output y. So what are the green line I was drawn over here? So that is nothing but a green line. That is nothing but my y is there. So I have to take y is equals to mx plus c, and I have to evaluate the y. So my m value is 0 and plus x value is 1, 2, 3. So multiple values is there, so it's not just only one or two values there. Here there is a multiple values is there. X is equals to 1, 2, 3, 4, 5, up to 10 we are having value. So we have to provide m is equals to 0 plus x is equals to 1 and c is equals to 40. So 40 into 1, 40 into 2, that's how the thing are working. But and then my m is equals to 0, so y is equals to mx plus c. So every time x should become a 0, so that's why we are getting output. It's a constantly 40. So that's how thing was working over here. If you can see the second diagram, so in this second diagram we are seeing like the things are coming up linearly. Okay, so we are getting over here the linear relationship. We are getting linear relationship like x 1, 2, 3 are there. So at the same time my value of m is equals to 0 0.8, but value of c becomes 0, so c are silent over here. So that's the type of thing we are getting over here, like how the thing are working in first diagram and second diagram. Now I just give you the 30 seconds to analyze the thing based upon the third diagram, and we can talk about like what are the things we are getting from over here. Okay, so I hope you can get an idea like how it should run over the third diagram. Okay, so whenever we are talking about the third diagram, so again y is equals to mx plus c. So here m is also present and c is also present. So if you can see, if you can combine the whatever the value we are getting over here for the first one, y is equals to 0, so it should starting with the from this 40 and it will complete it till 100, because that is a combination of first diagram and second diagram, and based upon first diagram and second diagram we are getting the third diagram. Because in a first diagram we have to take an m is equals to 0 and c is equals to 40. In second one I have to take an c is equals to 0 and m is equals to 0 0.8. But in a third diagram we have to combine everything, and based upon that we have to try it out something prediction. So here we have to just only evaluate the things like how variable affecting a regression equation. So that is the important part over here. So after completion of that one, now let's talk about some of the thing based upon a solving linear regression. You already seen over here the equation is there, but before that we have to learn about something like similarly look like the previous slide. Again we put the value of theta 0 and theta 1 over here. So here we are not doing anything new, we are just only replacing y is equals to mx plus c as replacement of theta 0 plus theta 1 into x. Every time theta 0 and theta 1 should be presented, and based upon theta 0 and theta 1 we have to try to predict like what is the value of h theta of x, because that is the important part is over here. So first of all we have to take in that h theta of x is equals to theta 0 plus theta 1 into x. So x value is 0, 1, 2, and 3, but theta 1 value is 0. So similarly look like previous slide, like c is equals to 40 like constant. So here we are also getting theta 0 is equals to 1.5. So in a first graph we are getting constant 1.5 line. Similarly, in second thing, we are getting idea like z theta 0 should be constant. So now it's time to 0.5 into 1, 0.5 into 2, and 0.5 into 3. So that's how linearly relationship we are getting. But if we combine the parameter of theta 0, it is 1.5, or the theta 1 is equal to 0.5, that type of thing if we can combine, so we are getting third diagram. So if you can see over here, so you can get the idea like how it should work over here. So that's how the thing are working in this solving the linear regression. Then we can also talk about like how it should work, and we basically that's how based upon h theta of x is equal to theta 0 plus theta 1 of x, based upon that the total linear regression should be worked. So that's how this session should be over here, because in this session we have to talk about like how regression should be worked, and particularly we have to discuss about some real world application. We have to take on some housing price example, like how it should goes and how it should work. From the next session we have to talk about like mean square error and multiple cost function. And in this practical session we have to learn about the simple linear regression. So let's start with the simple linear regression. In a first step, that is the import the library. So firstly I also mentioned over here like as a step one. So step one, import the libraries. So which libraries we have to import it over here? First of all, basically we have to import over here NumPy as np. Second library is import pandas as pd. After importing NumPy and pandas, the next library, that is the import matplotlib dot pyplot as plt, and then we have to provide the backend line for that, that is the matplotlib inline. So we already imported all the libraries, and the last library that is important library, and that is the cbon. So import cbon as sns. So here all the libraries we had imported over here, we have to just make it one mistake, import pandas as pd over here, cbon as sns. Okay, so all the libraries are imported over here. In a step 2, what we have to do, in a step 2 we have to import a data set, import a data sets. So all the data sets related to the our course are provided into the source section, but still how to provide your data set to out the coding. Okay, so that's the things we have to see over here. So basically you have to create one folder, and the folder name, that is a simple linear regression, and particular in this linear regression I already make it over here the data, and my data, that is the salary data.csv. So you have to create one folder, and particularly in that folder you have to provide your file, your dataset file, as well as what are the coding file you are creating now, that the source location is also the same file are there. So if you are doing the same thing, so at the same time it is easiest way to import the data set. So let's see how we can import the data set over here. So that's why first of all we have to take data set is equals to pd.read plus csv. Data sets are available in the csv format, so that's why we have to apply dataset is equals to pd for the pandas library and read csv, because dataset are coming in the csv format. That's why we have to make it with the csv format. That's why read csv are there, and simply we have to provide the particularly dataset name. So dataset name, that is the salary slash data dot csv. So that is the data file is there. And now once you can run this code, so you are getting the data set. So first of all I can show you how you can do the same thing. So here, that is my data set. So data set are having the years of experience and salary. There is total 2 parameter is there, and salary is depends upon the years for experience. So that's why years experience are performing as an independent parameter of x, and salary is the dependent parameter based upon the x. But still before that, let's do some basic analysis of this data set. Like we have to find out what are the basic functions that provided with the pandas to do this type of analysis, like dataset dot head of 5. So at the same time we are getting top 5 sample of the data set, as well as if we can provide the function like dataset dot info. So at the same time we are getting all the information based upon the data set, like how many number of columns are there, how many number of rows are there, and also years of experience as well as salary are having which type of the data type, and how many null object are there or count are there. So how many missing values are there, you are also getting that idea based upon this data set information. You can also find out the dataset dot size or dataset dot info. Dataset dot size, you are also getting the information based upon over here. NumPy integer is not callable, so that's why we are going with the dimension of that part. So dataset dot size, so here total size of this dataset, that is just only the 60. So that's how many more functions are there to analyze the data based upon simple things related to the pandas library, as well as with the NumPy library. So let's create x and y parameter. So we want to consider x as a year of experience and y as a salary. So for that we have to provide some type of the indexing things or the graph things over here. So whenever you want to provide this type of thing with the particularly with the pandas library, you have to use iLocation function. So that's why iLocation is stand for the integer location. So now if you want to select all number of rows, so that's why you have to use the semicolon for the rows. And if you want to just only use the particular first column of your data set, that is a year of experience, so you can also provide some type of the logic like -1, or you can also take it over here the 0 as well. So that depends upon you. If you want to take it 0, you can also take it that one. And if you want to take it this one like -1, so that is the meaning of this column is also years of experience. Same thing you have to apply for particularly y as well. And then we have to provide the values. For y, we have to take in some same parameter or same logic like data set dot I location, and with that particular again we have to use all the rows, and from the column we have to use just only first column or the first position of column. So that's why we have to take on 1 over here. And after applying this one, we have to find out these things. So here we are getting our x as well as we are getting our y. So x is like years of experience 1.1, 1.3. This type of data we are getting over here. And in terms of y, we are getting this much of salaries are there. So that's how we are able to create x and y dependent parameter and the independent parameter. Next things we have to see about how to split the data set into the training set and the testing set. Now we have to see how to split the data into training part as well as testing part. So basically we already known like training part is also considered with the 70 percentage of data as standardly, and the testing part are coming with the 30 percentage of the data. So let's see particular for that we have to create 4 parameters: x train, x test, y train and y test. X train basically coming from the test training set that is based upon some of the some or all of the independent parameter of x side, and x test is depends upon the particularly independent parameter of the testing side. Similarly, y train should come from the training set, and particularly in the training set, those are the dependent parameter from the training side. So, and also at the end, y test is coming from the testing side. With that, we have to predict the particular final answer that is depends upon the y test. So let's check it out the step number 3. And here the step number 3 is training and testing data set. So that is splitting is based upon a data set. That's why we are already created x and y. So based upon that, we can try to over make it over here something. So first of all, for applying training and testing set, we have to import one library, and that is depends upon the scikit-learn. So here we are using one library, and first of all, we have to import the library like from sklearn dot model. From sklearn.model, from sklearn.model, we are using one linear model. So that's why not a linear model. Linear model we have to use for the linear regression, but here we have to use model selection. So that's why we have to apply it over here the model selection. After applying the model selection, we have to import over here the train, test, and split. So we have to write down over here for train, then test, and then we have to write down for the split. So after applying the library or after importing the library, next thing we have to create xtrain, ytrain, xtest, and ytest. So let's start to write down same thing. So here we have to take an first of all xtrain, then we have to take an xtest. Second thing that is the ytrain, and then that is the ytest over here is equals to we are again call up our library that is the train, test, and the split. So based upon train, test, and split, now we have to decide how many percentage are coming as a training and how many percentage are coming as a testing. So first of all, we have to take an x and y that already decided like what are the independent parameter or variable or what are the dependent variable. Now we have to select the testing size. If we can take testing size is equals to 0.30, it means we have to take a 30 percentage as a testing size and 70 percentage as a training side. You can also take it 0.33, so that will also look like similarly to 1 divided by 3. So many ways, many terms of ways you can provide the test size over here. You can also provide the train size, but out of train size and test size you have to provide just only one thing. You can also take it as a 1 divided by 3, so it's look like a 0.33. And at the end we have to provide some type of the random state. So here basically for now we are taking random state is equals to 0, and now it's time to run this code. we are getting an error. Let's check it out on where pages we are getting yes, yes, yes. We forgot the one thing over here. We are not able to any type of the parameter with the blank space. We have to provide this underscore over here. And now this step is already running over here. Now in the next step, what we have to do here, we have to create our linear regression model with the help of the scikit-learn. So let's start with the linear regression model. So first of all, we have to import the sklearn model from the linear regression. That's why we have to write down sklearn dot linear slash model, because I want to take a linear regression from the linear model part. That's why we have to take in this one, and then I have to write down the linear regression. So library is already imported over here, and after importing the library, now it's time to create a model, and model is equals to simple what we had to make it over here, that is the linear regression. After applying that one, now we have to try to fit our model with our x train and y train. So that's why we have to take a model dot fit and particularly fitted with the parameter of x train and second parameter, that is the y train. And now we have to run this code. Here we are getting an error. I think I'm getting an error based upon some type of the spelling over here. Let's check it out. What are the issues we are facing over here due to the spelling? Sklearn linear linear model. Then we have to take an linear regression. So I think everything is should proper over here. Let's check it out. Still, what are the issues we have? We cannot import the name linear regression. So I think linear is complete with this part. We have to check it the error, like what type of error we are getting over here based upon our model. Okay, so we have to forward over here this bracket, and based upon this bracket we are getting an error. So now the error was solved over here based upon the linear regression, because I just forgot to provide this bracket over here, because without bracket the linear regression is not able to work with the x train and y train. So that's how the model is already built over here. But still, in between of training set and testing set, after the linear regression model, if you want to find out what are the values of x train y train, so you can check it over here. Like x train, you can write this code for everywhere, like x train y train, y test and y train. After getting idea about the linear regression model, the model is already prepared over here, and now it's time to prediction. So let's take a next step. Already we done a third step, that is based upon a training and testing set, and the step number 4, that is the machine learning model, like linear regression model. Now we have to see in step number 5. So step number 5, that is the prediction of y test based upon the test results. So prediction of y test based on a testing set. Okay, so for that, here we have to find out the y prediction. So y prediction is equals to model dot predict. We have to use model dot predict function with the help of the x test that we already created over here. And now we have to run this code, and again we have to overwrite down the y prediction, the answer we are getting over here. So based upon the years of experience and the particularly the salary, we are making one training set, and based upon that training set here, we are getting the Y prediction. So what are the X tests according to we are getting over here the Y prediction. So let's find out what are the X tests are there. So whenever the years of experience is 1.5, the salary is around 40,835.105. So that's how we are getting this type of salary over here. Whenever the experience is 10.3 years, so at the same time salary is 1,23,079. So that's how things are working over here. So based upon training set and testing set, now at then let's see in a particular step number 6, it's time to make a plot between training set result and testing set results. So step number 6 is depends upon the visualizing the training results. So now let's take it out. First of all, we have to use plot function, and with the help of plot function, we have to try to make it a scatter plot. So scatter plot here build up an x train and y train, and also we are having one option to set the color for the sample. So we have to take an x train. Next we have to take a y train, and after we have to take an color, and color that is the red color. That is the red color. I want to take it as a sample. After applying this one, now we have to take an plot dot plot, and particularly in that next thing we have to taken again we have to taken over here the x train, because here we have to select our parameter scatter plot that is based upon a x train and y train. But at the end here we have to create one hypothesis line in regression or the linear regression that is built upon the x train and the our linear regression model. So that's why here we have to use the model. That's why we have to take a model dot predict, and particularly with predict we have to take on the input parameter of this thing, that is the x train, because these all things we can do for the training results. Whenever we can do everything for the testing result, at the same time we have to use input from the testing set. And now the hypothesis line will represent in a blue color. After completion of these things, now it's time to provide the x label, y label, and the title. So let's start it with the title over here. And the title of this plot, that is the salary versus experience on a training set. Similarly, same thing we have to do for the next one. Next, we have to make it a plot dot x label. In particular, for the x label, we have to provide the years of experience. And in a y label, we have to provide the salary. Here we have to provide the salary. So all the thing was completed over here. And now it's time to show the plot dot show. Let's check it out. We are getting error of the graph. Yes, we are getting a graph over here based upon a training set results or training set visualizations. Similarly, in a step number 7, we have to do same thing but based upon a test set results. But let's check it out. What are the things we are getting on a training set results? So these all are the samples are there, and according to these samples, we are getting one proper hypothesis. But whenever after applying a machine learning model on a testing set, we are getting some proper result as compared to the training set. So let's go for the step number 7, like visualize the testing set. Again, here we have to use the same code. At the same time, we have to change some of the parameter. Otherwise, whole code from the visualization that is looks similar for the visualizing the test results. So as compared to, first of all, you have to take an x train and y train. As replacement of that, we have to use x test and y test. Here we have to use y test, and also from here we have to use x train. But also here there is a thing was similar over here in particularly testing side. Just only one change we have to apply over here, that is x test and y test. So as an input we have to provide the data from the testing side. So as compared to the training set result of visualization, the testing set results of visualization gives the better idea according to the hypothesis. Also, if you want to do the evaluation of the performance, you can also create the y-test prediction based upon the regression of prediction based upon the x-test. So that's how in a simple linear regression we can see about the 7 step of the machine learning and also the linear regression model. So in a step 1, first of all we have to import the library. After importing library, we have to import the data set. After importing data set, we are finding out some basic information of the data set. If you want to do some data analysis things, so you can also do the data analysis thing after the step number 2 with the data exploration. But here we are concerned on a machine learning, that's why I'm not doing any type of the data analysis over here. But for your practice you can did. After that we can make it a training set and testing set based upon a 66% and 33% as a testing side. After that, we are making linear regression model, and based upon model, we can make it prediction, and based upon the prediction, we can visualize the training set results as well as the testing set results. So that's how simple linear regression is completed over here. In the next things, we have to see about multiple linear regression of theory. In this session, we have to learn about mean square error as well as how cost function should be applied in a linear regression, as well as many extra ordinary term related to the after evaluating the linear regression. So let's start with the mean square error. In standard words, the mean square error of an estimator, in terms of you can also understand like of a procedure for estimating an unobserved quantity, measures the average of the squares of the errors, and that is the average squared difference between the estimated values and what is estimated. Mean square error is used to measure the performance of a model. So here we are having two terminology. Y hat test is equals to prediction made by the model on a test data, and Y of test, that is the expected output. So Y test and Y hat test, it's both are the important thing, and both are getting as the actual output and the expected output. So based upon that, we are trying to find out the difference between y hat test and y test among all the samples. So that's why the objective is to design an algorithm that decreases MSE by adjusting the weights W during the training session. And the above function is called the loss function or the cost function. The value needs to be minimized. So that's why after discussing or after talking about the MSE, let's something talk about related to the how solving linear regression in terms of the cost function. So after finding parameter theta that minimize the least square equation like OLS, like operating list square is there, its order is as well as, and also called as a loss function. So j of theta will stand for the loss function. So here we have to take on this equation mathematically, but whenever we are going to learn same thing on a practically during the programming, at the same time, no need to take on any type of equation. Everything can coming with the scikit-learn library. So j of theta is equals to 1 upon 2 summation of I is equals to 1 to m. So here during the summation of I is equals to 1 to m, we have to take summation of all the samples from first sample to the last total number of sample. And it is not just only work for one sample, it should work like we have to find out the difference between actual and predicted for all the samples. And after all the samples, we have to provide that sum as well as. So this decreases the difference between the observed output h of x and desired output y. So that's how we can get some more idea about like how cost function should be work, like because j of theta will represent as a cost function, and that's why once we are trying to reduce this cost function, at the same time it should improve the accuracy as well as. So now we have to talk about like how to learn the parameter and what are the learn the parameter. So parameter learning error, whenever we are trying to apply any type of learning with the parameter, so it should improve the accuracy as well as it should improve the cost function. Like in terms of g of theta cost function, it should reduce, but the quality of that one, that should be improved. So there are two ways to learn this parameter. The first way, that is the normal equation. Set of derivative in terms of slope of the loss function to zero, and this will represent the minimum error point. Normal equation is an analytical approach to linear regression with a least square cost function. We can directly find out the value of theta without using gradient descent. And following this approach is an effective and time saving option when working with a data set with the small features. So normal equation is a basic type of things are there, but now we have to talk about one of the important learning parameter techniques, and that is the LMS algorithm. The LMS algorithm, it should be stand for the least mean square algorithm. And the minimization of the MSE loss function is called the LMS least mean square rule or a Withrow-Half learning rule. So the some of the people are using as LMS technique, or some of the people are also known as a Withrow-Half learning rule. This typically uses the gradient descent algorithm, but in technicality of machine learning, the gradient descent word is very popular. So the LMS algorithm introduced by Widrow and Hall in 1959 and is an adaptive algorithm. So the LMS incorporates an iterative and the procedure that makes successive correction to the weight vector in the direction of the negative of the gradient vector, which eventually leads to the minimum mean. So as compared of the both the ways for the learning parameter, the LMS algorithm is much popular due to the gradient descent concept. So let's do how we are going with this LMS algorithm and in future with the gradient descent. In case of linear regression, the hypotheses are represented with the y is equals to h theta of x. So h theta of x and hypothesis and y, both are the similar thing are there. So based upon that, we have to getting some idea about the theta 0 plus theta 1 into x1 plus theta 2 into x2. So where the theta will represent some of the parameters. Okay, so is our thetas are the parameters for number of samples or the weights. So thetas can be also be represented as theta 0 into x0 where the x0 is the initial input are there. So always we have to consider initial input is equals to 1. After that, we are getting this h theta h of x. So it is again similar, like h theta of x is equals to theta 0 plus theta 1 into x is there. And here we have to apply these whole things to each sample. So that's why the standard and easily understandable format is theta transpose into x. So what are the weights are there? We have to provide the weights to that, and we have to take a normal input. So the combination should become in terms of matrices. So after that, the cost function, also called as ordinary least square or the OLS, that should define is especially the mean square error. The one half is just to cancel out the two after derivative is taken and is less significant. So cost function is equals to one half summation I is equals to 1 to m h theta of x of I minus y of I. We have to take at the square bracket. So same thing we already discussed during the cost function, like g of theta, it's represented with the cost function, and it is advisable to start with random theta, then repeatedly adjust theta to make g of theta smaller. But once we can getting some values of j theta, then it's time to implement LMS algorithm. So here at the same time, if we can develop LMS algorithm in terms of gradient descent technique, so at the same time we have to provide the derivatives to particular cost function. So gradient descent is an algorithm used to minimize the loss function. So when we talk about the loss function, so gradient descent, it's a very good thing is there. But what is gradient descent in general words? Gradient descent is a first order iterative optimization algorithm for finding a local minimum of a differentiable function. So with the help of differential function, we are trying to find out local minimum or the optimal minimum or the global good solutions. The idea is take to repeated step in the opposite direction of the gradient or the approximate gradient of the function at the current point, because this is the direction of the steepest descent. So these are the things are considered over there. So let's talk about some of the fact related to the gradient descent. Like in the gradient descent, j of theta in dj of theta, it's a derivative of j of theta, and represent the cost function or error function. So cost function are having multiple names there. So one of the name is the error function that you wish to minimize the OLS or the minimize the mean square error. That is your final target is there, because we have to reduce this mean square error. So minimizing this would mean that y hat approaches y. In other words, observed output approaches the expected output. So at the same time, we are trying to make it same number as actual output and predicted output. For example, today I can predict like Virat Kohli will make 100 run, 110 run, and in actually Virat Kohli will make 105 runs. So that's good, but the error will start from big. I can predict like Virat Kohli will make 110 run, but Virat Kohli just only make a 10 run. So at the same time, my prediction will go very wrong. So other example of loss or cost function include cross entropy, that is y hat, y log y hat, which also tracks the difference between y and y hat. So that's how things should be worked over here, and we are getting some idea about the how gradient descent should be worked over there. Now let's talk about algorithm in step of algorithm, like how gradient descent should be worked in terms of LMS algorithm. So first of all, it should start from the slope of j of theta. It's the slope of cost function versus the theta parameter. So after that, we have to provide the derivative of that function. So we are getting perfect slope. After that, we have to adjust the theta repeatedly, and alpha is the learning rate. Again, alpha will play a major role when we talk about LMS algorithm. So this algorithm repeatedly takes a step towards the path of steepest descent. So steepest descent, or the when we talk about the equation of the theta j learning rate equations, at the same time it should prefer the learning rate as well as. So calculate derivative term for one training sample x and y to begin start this one. Again, I telling to you whenever we are talking about this mathematical, so mathematical are just only looks good when it's on slide or on paper, because during the practical we are not doing there's lots of mathematics things, because we have to implement, we have to use libraries to complete this type of stuff. So last step is based upon update rule for one training sample. So for that, again we have to go with the theta j is equals to theta j plus alpha of y of I minus h theta of x of I into xj of I. So that's how things are working over here in terms of how to update a one learning rule. Still, let's some of the more thing we have to talk about, like how the with the LMS algorithm gradient descent learning should work. So the graph here, we are getting this one graph. So in this graph we are getting some blue dots and yellow dots. So what is the meaning behind the blue dots and yellow dots? So this blue dot step size is depends upon the learning rate. So again, we have to learn about what is the meaning behind the learning rate. And the yellow point will represent the optimal global point. So whenever our blue point meets to this yellow point, so at the same time, our accuracy it should become 100% and error should become zero. So at the same time, we are getting mean square error is equals to zero. So the gradient descent is an optimization algorithm. So that's it's used when training a machine learning model. It is based on a convex function and tweaks its parameter iteratively to minimize a given function to its local minimum. So that's how things was working. But still, we have to lots of things are remaining based upon a learning rate and many more things are there. So now let's do some of the things like how it should go. The things or cost function are working under the iteration. So if you can see the rate point, it should represent the global maxima, and we have to touch down throughout the global minima. So global minima, whenever we are getting some global minima, so at the same time it should become my error should be a zero. So global minima, it's a perfect thing are there. That's why we are trying to near throughout the global minima. So that's why we can start a journey from red point to the blue point or the red area to the blue area. But if you can see this diagram, in this diagram, one more global minima is there and one more global maxima is there. So let's see how it goes for the global minima again. So that is the second global minima is there. So both the things are important when we are trying to find out what are the global minima. But these are the 3D diagram. That's why we are getting this type of thing. But when we are working with the 2D diagram, it means like when we are working with two-dimension thing. So it looks very proper because it just only use as a like inverse bell curve type of thing are there. Let's talk about the learning rates. So gradient descent are totally based upon learning rate. But what is the importance of learning rate and what are the popular values of learning rate? Basically, this learning rate or the gradient descent, this type of thing are also popular in deep learning. So deep learning neural networks are trained using the stochastic gradient descent optimization algorithm, and the learning rate is a hyperparameter that controls how much to change the model in response to be estimated error each time the model weights are updated. So gradient descent is important in machine learning as well as in deep learning. So what happens whenever the learning rate is low or the small? Whenever we are having learning rate is very very small. So at the same time, it should take lots of time to reach at optimal point. And also whenever it's try to near with the optimal point, it should take some more time or more extra time. So for that, we are trying to like we have to take learning rate as large. But whenever we are trying to learning rate is large, so at the same time, it should not easily converge with the optimal point. It should take like very small, large steps and may not converge to minimum, and error might keep increasing for further improvement. We are doing this gradient descent or cost function and this type of stuff to reduce the error. But whenever we have to take an large learning rate, so learning rate should be large as well as fast. So at the same time, the error should increase, but our goal is error should be reduced. So that's why slow learning rate or the small and fast and large learning rate are not possible. So for that, we are having just some of the values are there to make some learning rate. So that's why we have to follow some of the value like zero point 0.5 or 0.05, that type of things we have to use every time. So same thing are applied for the both the things, and that's why an epoch refers to one pass for the model training group. So after talking about these things, let's discuss more similar situation based upon a learning rate. So these are the another situations are there. These are not based upon a large or small learning rate. These are the some condition whenever we are getting in data as well. So not all cost functions are good balls. There are maybe holes, ridges, plateaus, and the other kind of irregular terrain is there. So if you can see this figure, if random initialization of weight start on the left, it will stop at a local minimum, and if start on the right, it will become a plateau, which will take a long time to converge to the global minimum. Fortunately, the mean square error cost function for linear regression happens to be convex function with a bowl with global minimum. So that type of thing are working over here during the gradient descent learning rate. So this session is ended over here. Basically, in this session, we have to mainly time spent within LMS algorithm and the gradient descent started with the mean square error. In next session, we have to just simply talk about what are the objective of linear regression, and the real world application or the use cases based upon a linear regression. Let's talk about objective of linear regression. The establish if there is a relationship between two variables, independent variable and dependent variable. For example, relationship between housing process and area of house, number of hours of study, and marks obtained, income and spending, etc. And the second thing is prediction of new possible values that is based on the area of house prediction, predicting the house price in a particular month based on number of hour studied, predicting the possible marks, sales in the next 3 months, and that type of things we are getting during the prediction of new values. After seeing about the objective of linear regression, let's see some of the more linear regression application or the use cases. So the first use cases should become from the real estate. In the real estate, to model residential home prices as a function of the home living area, bathroom, number of bedrooms, or lot size, or and many more thinking are available over there. Like when we are talking about this type of thing, so many housing price prediction applications are available over the net. If you can see, so you are getting some more application over the net based upon housing price prediction. The second thing, that is the medicine or the healthcare, like in field of medicine and healthcare, how the application of linear regression should develop to analyze the effect of a proposed radiation treatment on reducing tumor size based on a patient's attributes such as age or weight. The third application is demand forecasting to predict demand for goods and services. For example, restaurant chains can predict the quality of food depending on weather. And the last application based upon a linear regression, that is the marketing, with the to predict companies sales based on the previous month's sales and stock price of the company. Whenever you are having some large problem based upon a stock price, you can also go with the neural network, because some of the neural network are also work within this type of stock market price prediction. Simple linear regression is completed over here, and now from the next session we are trying to learn about multiple linear regression. So next session is based upon a multiple linear regression, and then so on we can also discuss about the polynomial regression. In this session we have to discuss about multiple linear regression. So with the multiple linear regression, we can learn many more terms like one hot encoding, dummy variable trap. With the last, we can also see one more type of the regression that is called as a polynomial regression. So let's start with the multiple linear regression. So what is the multiple linear regression? Multiple linear regression, it's also known as MLR, and it's also known as multiple regression. It is a statistical technique that uses several explanatory variables to predict the outcome of a response variable. Multiple regression is an extension of linear regression that uses just one explanatory variable. It is a statistical technique used to predict the outcome of a response variable through several explanatory variables and model the relationship between them. It represents the line fitment between multiple inputs and one output, typically W1 into X1 plus W2 into X2 plus B. So here we are able to use multiple inputs. When we are talking about the simple linear regression, at the same time, we are just only taken W1 into X1 plus B, like Y is equals to MX plus C. But here we are able to use multiple inputs. And the graph shows dependent variable Y plotted against two independent variable x1 and x2, and it is shown in 3D dimensional. More independent variable involved will increase the dimensional further as well. So let's see one hot encoding the multiple linear regression. Like when we are needed for one hot encoding, and first of all we have to find out what is the meaning of one hot encoding. A one hot encoding allows the representation of categorical data to be more expressive. Many machine learning algorithms cannot work with the categorical data directly, so the categories must be converted into numbers, and this is required for both input and output variables that are categorical. When some input are categories rather than numbers, we need to represent the category value as a numbers so they can be used in our regression equation. So here we have to find out on which, based upon which column we are able to apply one hot encoding. So from this table we are able to apply we have to apply one hot encoding based upon a state column. because in the state column we are having New York and California, two type of state is there. So after one hot encoding, the next step, that is dummy variable. So in a dummy variable, we are continue the process of one hot encoding. In statistics and econometrics, particularly in regression analysis, a dummy variable is one that takes only the value 0 or 1 to indicate the absence or presence of some categorical effect that may be expected to shift the outcome. So from this table, based upon a New York and California, we should create a dummy variable. So here, if you want to neglect one column from these two, that is also possible, because both column can should become each other inversely proportional, because when New York are having one, also California are having zero, and whenever New York are having zero, California are having one. So that's why we are getting an idea both the things are inversely proportional to each other, because in a state column we are having just only two things, like New York and California. Within continue this topic, we have to also evaluate the things like whenever it should become inversely proportional. At the same time, you can also consider the dummy variable as a switch variable. So on and off is there. Whenever the New York will on, at the same time California should off, and whenever New York should off, so California will on. Now let's talk about the one important thing related to the dummy variable, that is the dummy variable trap. So what is the meaning behind the dummy variable trap? The dummy variable trap is a scenario where there are attributes which are highly correlated or multicollinear, and one variable predicts the value of others. When we use one hot encoding for handling the categorical data, then one dummy variable can be predicted with the help of other dummy variable. So from the equation of d2 is equals to 1 minus d1, we can prove inversely proportional thing. And to avoid the dummy variable trap, always omit one dummy variable. So you can always go with the just only one dummy variable. You are not able to going with multiple dummy variables. So dummy variable is just only applied whenever your column are having like state and just only New York and California. This type of two states are available. Otherwise, you are not apply the dummy variable. So there is no necessary to rise like a dummy variable type. So otherwise, in this multiple linear regression, gradient descent working similarly like a simple linear regression. So that's how over here, the multiple linear regression should be completed over here. And let's talk about the polynomial regression. So polynomial regression, what is the polynomial regression? But polynomial regression, everything is depends upon a degree. In statistics, polynomial regression is a form of regression analysis in which the relationship between the independent variable x and the dependent variable y is modeled as an nth degree polynomial in x. So all through this model allows for a nonlinear relationship between y and x. So polynomial regression is still considered linear regression since it is linear in the regression coefficient. So in a linear polynomial regression, everything is based upon a degree. So during the coding or programming, whenever you are applying different types of degrees, so at the same time, the shape of the curve should be different. Whenever degree should be zero, the shape was horizontal, and whenever we have taken degree is equals to one, at the same time, shape should be linearly increased. So that's why, according to our data, we have to provide some different cubic function, quadratic function, and quintic function. So we are getting some more idea about the polynomial regression. Polynomial regression is applied when data is not formed in a straight line. See, whenever the data is coming look like a linear relationship, so no need to apply polynomial regression. But when data should be different or data should be in like non-linear type of things are available, so then we are going with the polynomial curve or the polynomial regression. So it is used to be fit a linear model to a non-linear data by creating new features from powers of non-linear features. So that's why we are going with some quadratic features in terms of squares, cube roots, and 4 power, 5th power, or 6th power. So again, in polynomial regression, gradient descent should be worked similar to the simple linear regression. But whenever we are trying to apply polynomial regression, so at the same time, most of time, no need to apply any type of the gradient descent or LMS algorithm, because whenever we apply the polynomial regression, almost time we according to the power we are getting some proper accuracy. So no need to apply more LMS algorithm or the gradient descent type of thing. So this session should be ended over here, and from next session we can starting something with the classification algorithm. In this practical session, we have to do some practical coding based upon a multiple linear regression. In previous one, we had already seen about a simple linear regression, but now we have to see about the multiple linear regression. So first step, that is the import the libraries. So first of all, we have to import the library, and that is the import numpy as np. Second library, that is a pandas library, import pandas as pd. After that, we are also using a matplotlib library. That's why we have to import the code import matplotlib dot pyplot as plt, and also we have to use this backend line, that is the matplotlib inline. So after importing all the libraries, now we have to import the data sets. So particularly for this multiple linear regression, I want to work with the 50 startup data CSV. So basically data set is already still provided in this my particular location, and in multiple linear regression folder, data set is already provided particular with the location. Now that's why it is easiest task to import the data set with the particular location. Now I have to create the data set over here, and again I want to use the CSV data set. That's why we have to use pd dot read slash CSV, and with that we have to import the things related to the 50 startups. So the dataset name is the startups dot CSV. So after providing the name, now it's time to import the dataset over here. So dataset is already imported over here, and now let's check it out. The dataset is imported completely or not. Basically here we have to work with the multiple linear regression. That's why we are using multiple independent variable and just only one dependent variable. So let's find out what are the independent variables. So here we have to take an R&D spend, administration, marketing spend, and state we are using as an independent variable, and as compared to that, profit should be play as a role of the dependent variable. So that's why it will stand on the 0 1 2 0 1 2 3 and 4. So fourth position is represented with the y. So let's create x and y first of all, and after that we should create a training set and testing set. But here that is a multiple linear regression. That's why we can also see about how to apply the one hot encoder and the dummy variable. And also for avoid to trap of dummy variable trap, we can also see about that particular code. But before that, we have to first of all find out how to create as x. So for that, we have to take dataset dot I location, and with that particular I location, we have to use semicolon, and then also we have to use semicolon of -1. So that's why aspect to the profit column, all other column are look like a independent variables. So after applying x, now it's time to apply the y over here. So particular in a y, we have to take on a data set. Here the data set, again we are using the I location, and particular with the I location, we have to provide the select the all the rows, and with that we have to just only select the last column, and at then we have to provide the values over here. So after applying this code, now we have to run this code. So now x and y is already find out over here. In the next step, what we have to do, in the next step we have to apply the encoding to our categorical data. If you can see in the third column, that is based upon a state, and particularly in this state I have New York, California, and Florida. So these three states are there. So based upon that, we have to create a one hot encoding concept over here. So for that I can provide one comment, and that is the encoding categorical data. So after applying that, first of all, to apply the encoding, we have to import the one library based upon the encoder, that is the label encoder and one hat encoder. But in this library, we are getting from the sklearn. So sklearn dot pre-processing, sklearn dot pre-processing, and from that we have to import a label encoder, and the second thing we have to import, that is the one hot encoder. So one hot encoder. And now we have to again run this code. So here we are getting one error, cannot import a name one hot encoder. It's a wonder, not a wonder. It's a just only one hot encoder. Now it's running the library over here. Now let's start it with the coding part of the particular thing. So here, first of all, for that, we have to create a variable related to the label encoder is equals to, we have to take on this one label encoder of bracket over here. And then in the next step, we have to take an x because we have to select this particularly state column. So that's why according to the indexing and slicing concept, we have to select all the number of rows and just only the column of state, and with equal to we have to take an label encoder. And after applying label encoder, in the next thing we have to transform these things with the particular of the input. So that's why we have to use feet slash underscore transform. So after applying feet underscore transform, we have to take an x, and particular with the x we have to take a number of all the number of rows, and particular for the column of 3 we have to take. So now we already provided our input to over here, and after in this step, next step, we have to find out, or we have to create a variable for the one hot encoder. So let's create a variable for the one hot encoder. So one hot encoder is equals to, again we have to use our source name one hot encoder over here, and after applying a one hot encoder, just a second, I have to take on some capital and small, and you have to follow the capital and small according to the libraries. And under that one, you have to apply the categorical feature to particularly one hot encoder. So we have to apply the categorical features. Categorical features is applied, and that is applied based upon the input number 3 or the position number 3. And after at the end, in the last thing, we have to apply this encoding to our input. So that's how we have to apply the same thing over here, and based upon that we have to fit it the things, and at the end we have to transform the thing as well as. Also we have to apply it of x. We have to apply the same thing over here. So we have to apply the x over here, as well as to particular with the array we have to join the same thing. So for that we have to use to array. And now it's time to run this code, but here we are getting an error. I think the error is based upon some type of spelling mistake. We are getting an error in second line, the label encoder. Okay, the second line we have to take a label encoder dot fit, and we have to take an fit transform, but I think we have to take it over here the space. Let's check it out. Still we are getting an error. So we have to check it out what type of error we are getting over here based upon the what things, because there is spelling mistake. If you can make it the one spelling mistake, that will at the end it will gives you the error. So it's a spelling mistake like label encoder. We have to use this same one. For that I have to copy that one, and I'm trying to paste it over here because somewhere that cannot just only work like similar to that way. Let's check it out what are the errors. We can change, we can apply some more changes over here. Okay, so here the error is based upon the transform spelling trans, and the mistake is based upon that again. The name one hand and one hot encoder is not defined. We have taken yes, one hot encoder is equals to, again there is a r is there, so sometime yes. So now the code will run over here. The library is already running over here, and also the code was correct over here. Now we have to take step to avoid the dummy trap. Now we have to take a step, avoid dummy trap, because if we are just only having the one where just two categoricals, so at the same time it should also work look like a switch function. We already seen all this concept in particular theory of the multiple linear regression. And now to avoid the dummy variable, we have to provide the function over here that is look like this one, and now we have to run this code. So after doing all these things, the next step that is based upon a training set and the testing set. So for that, we have to import the sklearn.model selection. So let's import the sklearn model selection, and based upon that, we have to import train, test, and split. We have to import train, test, and the split. So after doing that one, now it's time to create X train, Y train, X test, and Y train. So first of all, we have to create X train. Next, we have to create the X test. Then we have to create the Y train, and then we have to create the Y test. So after creating all four parameter, now again we have to use train, test, and the split. So after getting this all one, now we have to take an X values, Y values. After x and y, now it's time to decide what are the test sizes. So here I want to take it, test size is equals to 0.28, means 80% of training data, and 20% of the testing data I want to use over here. And at the end, we have to take a random state is equals to 0. Basically, random state should apply to getting how to split the data into training and testing. If we can take in some type of random state at the same time, some instance, they are selecting the X train, X test, Y train, and Y test. So that's how random state should be work over here. And now it's time to create a multiple linear regression. So for that, we have to import the library from sklearn model, sklearn linear model. Here we have to use the linear model. Here we are not using any type of the particular model selection, but here we have to use linear model, linear slash model. And also here we have to provide one dot sklearn dot linear model, and from linear model we have to import a linear regression. So similar things we have to import over here, but we can use the last linear regression practical. So after importing linear regression, next thing we have to create a model, and model is equals to linear, then regression of the bracket. Don't forget this bracket. And at the end, we have to fit the model with the X train and the Y train. So that's why we have to use X train over here, and then we have to use Y train over here. So after applying X train and Y train, we are getting the output, but still here we are getting an error. I think there is again spelling mistake is there. SK learn dot linear model. So here I just take the capital L, but here there is a small L is there, and the model is already prepared over here. So similarly, look like a simple linear regression. That is your home task, or that is your homework. You have to create the training and testing visualization based upon this model. Now, in a lastly, I just only make it just one thing, and that is I have to create the parameter based upon the Y prediction, and Y prediction is equals to the regressor, or you can also take it a model dot predict of X test. So based upon X test, you are able to make it a Y prediction. So in the Y prediction, you are getting the final answer. You can also parallelly create over here the X test. So you are getting an idea what are the inputs. So input are the different type of inputs are there. But still, if you are having an question, why input are getting 1.00 and 0.00, this type of input you are getting due to the label encoder and the one hot encoder. Whenever you are using the label encoder or the one hot encoder, and it is also look like a data pre-processing things. So that's why your input should be transforming within some standardization and normalization type of things. We already learned about the data pre-processing topic related to the standardization and normalization. So one hot encoder or the label encoder should work similarly, particular with the multiple linear regression. So next topic, that is the polynomial linear regression. In this practical session, we have to learn about polynomial regression. So already library was imported over here, and dataset is still code was ready to over here. Again, we have to use pandas.read.csv because we have to work with the CSV file and the dataset name, that is the position salaries. So now we have to run this code as well. Let's figure out how data is looks. So for that, we have to find out the data set dot head. So based upon data set dot head, we are getting an idea how the data set should look. So data set dot head. So here basically in this data set we have three columns: position, level, and salary. Basically, you can also apply in the particular polynomial regression as you can also consider as a multiple linear regression. So you should take position and level as an independent parameter and the salary as a dependent parameter based upon the dependent parameter. So now it's time to find out what are the x and what are the y. So here we have to first of all take x is equals to dataset dot I location. It means integer location, and based upon that integer location, we have to provide first of all here I have to use all the rows. So that's why I have to use semicolon. And after applying semicolon, we have to select some of the particular column. So for here, I want to use as an input, I want to take it one semicolon two. It means 0 1, so starting from 1 and it will end it before 1. So just only label column I want to use it as an input currently. So 1 semicolon 2, and based upon that I want to take it a values over here. Now it's time to select the y, and in particularly y I want to use it y as a salary. So here I'm not using the position column for the this parameter. So that's why the x is equals to level and y is equals to salary. So again we have to provide the data set dot I location, and particular with that I location we have to provide the semicolon, and with the semicolon, we have to use the second parameter as a column. So second column, that is the salaries. And after that, we have to take it values for that. And now it's time to run this code. Let's check it out. What are the x? So x are 1, 2, 3, 4, 5, 6, 4, 5, 6, 7, 8, 9, 10. That is depends upon the level, and y is depends upon the salary. So we are also getting the results based upon that salary. Particular in this problem, we are not applying any type of the encoder or the one hot encoder because we are using single variable as the input or the single variable as output. Now it's time to apply the training set and testing set. So let's see, you already know how to apply the training and testing set. For that, first of all, we have to import sklearn dot model selection, and based upon this model selection, we have to import the library that is based upon train, test, and split. So we have to import train, test, and split. After applying that one, so here we are did spelling mistake sklearn, and then we have to find out xtrain first of all. Second thing we have to take on that is the xtest. Third thing, here again we have to even two times test. Now next we have to take on y train, and last we have to take on y test over here. So y test is the last thing, and here now we have taken train, test, and the split. And based upon train, and split, we have to select x, y, and we have to find out what are the test size. So here I want to take it test size is equals to 0.2. It means 80% of training data I want to select over here. So that's why here we have to take random state over here is equals to 0. So now it's time to run this code, and this code is running properly. But still, if you want to apply any type of the feature scaling, so we can able to apply feature scaling over here based upon the level like 1 to 10, because according to the salary we have to assign the things. That's why. So let's see. First time we are seeing about how to apply the feature scaling topic. So that's how we are applying a feature scaling. Basically, in a feature scaling, we have to use standard scaler. So for that particularly, we have to import the library from the sklearn preprocessing. So first of all, from sklearn preprocessing, we have to import a standard scaler. So for that, we have to use capital S, then standard, and then we have to take a scaler. So standard scaler. So according to the standard scaler, we have to take an sc underscore x is equals to standard scaler. But you have to mention one thing: the s was capital in particularly standard scaler variable. So here in this particularly standard scaler, we have to take on one bracket, and also you have to good familiar with the spelling of standard scaler because LER is there. Okay, so after applying that, we have to provide the standardization to the X train and X state. So that's why we have to fit the data with the X train first of all. So X train is equals to SC underscore X dot fit and transform with the old X train, because here we are trying to create a new X train. That's why. Similarly, we have to apply the same thing with the X test is equals to SC underscore X and dot we have to fit. Here we have to take FIR, we have to take fit, and then we have to take transform, and also here we have to take an X test. And now we have to run this code. So code is properly run over here, and in the next stage we have to making a model. So first of all, we are trying to make a model based upon a linear regression, and once linear regression should applied, then we should convert linear regression into the polynomial regression. Let's make a code for the linear regression. So for you making a linear regression, first of all, we have to create the linear regression. That's why we have to import the model for the linear regression. So from sklearn dot linear model, sklearn dot linear model, we have to import a linear regression and import a linear regression. So linear regression is coming over here. After applying that one, we have to create a model. So that's why now I'm providing the model name, that is the linear regression, and also we have to equate the model over here, linear regression. And after making that one, next thing that is based upon a linear regression with the fitting the model of X train and Y train. So linear regression dot fit of X train and y train. So that's how we can do over here. After making this one, now we have to run whole the code, and linear regression is already prepared over here. Now, in the next step, we have to fitting a polynomial regression to the data set. So that's why we are trying to convert linear regression into the polynomial regression with the help of the polynomial feature or the degree of the polynomial. So let's do the same thing over here. So again, to importing the polynomial regression or the polynomial features, we have to use sklearn preprocessing library. So from sklearn preprocessing, sklearn dot preprocessing, we have to use sklearn dot preprocessing. We have to import over here the polynomial features. So polynomial, so we have to take features. After applying polynomial features, we have to create one or more parameter, that is the polynomial regression are there. And the polynomial regression are there. So here, based upon that one, we are using a polynomial feature with the degree of 4. So we have to write down the polynomial features with the degree is equals to 4. So after applying degree is equal to 4, now here we have to provide the x of poly is equals to poly. Poly is the function for that. So you have to remember the what are the poly things you can use till now, like poly and with the regression. And now you are trying to polynomial regression is fitted with the transforming of the x train. So till now we are already pre-created the x poly, and in the next step we have to fitted the polynomial regression is fitted with the x poly and the y train. So here basically we have to replace x train with the x polynomial. So that's why here we have to provide what are the inputs with the degree of 4. So that depends upon you. You can also provide the degree of 4, 5 or 3. That is depends upon the problem statement. So according to our problem, the degree number 4 or degree is equals to 4. That is the appropriate things over here. So now we have to taken like poly and then regression dot fit of x poly, and second thing, that is the y train. So based upon x poly and y train, we have to make this task. And now we have to make it linear regression of 2. Linear regression of 2 is equals to, here we have to use this linear regression. So that's how we are getting idea over here. And at the end, we are making a new parameter or new variable that is based upon a linear regression 2. So what we already created, like linear regression 2 dot fit. So here basically I can use the polynomial features with the linear regression. So that's how we are getting output related to the polynomial regression. So that is the best way to get the polynomial regression in the output. So now it's time to run, and good thing that is that we are not getting any type of the error, and we are getting the perfect output over here. So after applying this one, now it's time to make it the visualization of data based upon the polynomial function. So we are getting an idea what type of things we have to do over here. So let's do first of all visualizing the linear regression results, and after that we can see the visualization of the polynomial regression of the things. So let's start it with the first of all linear regression things. So for linear regression, we can starting with the plot dot scatter, because we are using the scatter plot over here for the input, and we have taken x train over here. So here I have to take an underscore over here, and we have to take an x train. Then we have to take an y train. And after applying x train and y train, we have to take a color. Color is equals to, here I want to take it a red color in terms of the samples. After applying that, now we have to take plot dot plot, like plot for the function of the matplotlib, and now we have to fit it the things related to the linear regression over here. So first of all, here I have to take x train, second parameter, that is the linear regression dot predict, linear regression dot predict of x train. And after applying this one, we have to use one color, and color is equals to here the blue. So blue color we are using in terms of the hypothesis line. After doing this one, now next thing that is the provide the title, also the provide the X label and Y label. So I'm not providing that things. That is your homework. Whenever you should do the same thing, you can create the title. So here I just mentioned the comment over here. So create a title, X label and Y label. Now just directly I can apply the plot dot show, because we are getting the visualization is the important thing out there as compared to the title, X label and Y label. So here we are getting the output is look like this one. So here we are getting an idea how the thing should work over here when we should apply the linear regression on this particular data. If we can apply the polynomial regression on this data, so what type of output we are getting over here? Let's check it out the same thing over here. So for that, I have to again use these things over here to getting this one. For this one, we have to use this one over here. After applying this, I again want to use this one, but at the same time, we have to provide some of the changes over here. So based upon that changes, we are getting an idea how the polynomial regression should provide any type of the effect to over here. So first of all, here we have to take an X train, and also we have to take an here linear regression dot predict. But as compared to linear regression or dot predict, we have to use linear regression of the two. So we have to use linear regression underscore two. Again, I have to check the name of what are the name we had created over here. Yes, to predict with the particularly X train. Let's see, we are getting an error. Yes, we are getting an error. I think we have, yes, the samples are getting correct, but I think hypotheses are getting some stuck. Okay, no problem. We can change it, the particular one. Yes, we have to change this one as well as like after providing this one, we have to rechange like this one. After providing the linear regression to predict, we have to also provide the polynomial regression line. Okay, so that's why we have to take an polynomial regression dot fit, and with that fit we have to also use the transform function to get these things. So we have to provide transform of x, and also we have to provide the double bracket to complete this one. Let's see, still we are getting an error. I think we are getting an error based upon the input. I think yes, the dimension are not matched. Okay, so dimension are not matched. I think we have to take an over here as well as x dimension. Yes, now it looks perfect. So now it looks perfect. Okay, so that's how the things are with here. So if we can take on this type of samples, and with that samples, if we can provide the polynomial regression, so the we are getting the perfect line in particular in terms of the prediction. Here we are working with the training set, sorry, the testing set. That's why we are getting the less samples. Okay, but if you can do some more practice based upon this type of data sets, or you can change some parameters things, so you can get some proper output with the polynomial regression. Next, we have to see about the decision tree as a regressor. In this practical session, we have to learn about the logistic regression. Already theory of the logistic regression that should be over, and now we are going to learn about the practical aspects of the logistic regression. So in the starting, we have to follow the first step to import the libraries over here. So you already know what are the important library we are used in particularly regression topic. Same library we have to use it over here in terms of NumPy, Pandas, and Matplotlib. So first of all, we have to import NumPy already imported over here, and second library that is the Pandas as PD, and third library that is based upon a Matplotlib. So we have to import Matplotlib dot pyplot as PLT, and we can also take in some backend line like Matplotlib inline. So after providing all the libraries over here, in the next step, we have to provide the data set. So you already know we have to create one folder, and in that particular folder, we have to provide the data set as well as this logistic regression file we can also create in that particular folder. So basically, for this practical, I want to use it a data set that is the social network advertisement data set. So based upon social network advertisement data set, I want to predict or I want to classify the things look like, okay, like the person will purchase the product based upon the advertisement or not. So we have to solve the binary classification. So let's pd dot read CSV because data set is available in the form of the CSV. So here we have to provide the social, then network advertisement. So the short form that is ADS, and then we have to use the CSV extension over here. And we can also see in dataset dot head. So top 5 samples of dataset we are getting over here: user ID, gender, age, estimated salary, and the purchase one. So after applying this one, the next task we have to do some data analysis, as well as we are also able to create X variable and Y variable. So basically, you can take it a gender, age, and estimated salary in terms of the X variable, and for Y variable, we have to use the purchased. So particularly when you can work with the logistic regression, so it does not look like that we are not able to take more than one parameter in terms of X. So we are able to take more than one parameter or two parameter particular for the X. So let's take it X is equals to age and estimated salary, and particular for the Y we have to use a purchase column. So for that we have to take an X is equals to dataset dot I location, and particular that one we have to provide the semicolon to access all the rows, and to access the column we have to take it 2 and 3. After we have to apply the values over here. Once we can done this one, then we have to take it y is equals to dataset dot I location. Also we have to use this bracket, and also we have to access all the number of rows, and with that we have to just only access the particular fourth column that is depends upon the purchase. On zero position we are having the user ID, 1 gender, 2 age, 3 estimated salary, and on the fourth position we are having the purchase column. So after applying these things, we can also find out is there any missing values are available in this data set or not. So for that, we are using isNull function. We already aware about the isNull function, particular when we should work with the pandas library. So with the isNull, we are getting an idea, is there any missing values or not. So everywhere I'm getting the false, it means no missing values are there. If you want to get some data set information, you can also follow the same thing as well, as like dataset dot info. So throughout that you are getting an idea how many missing values are there. So always, if you can see over here, in every particular column we are having 400 non-null count. So it is the meaning is that we are not having any type of the single missing values. So after applying importing libraries and the data set after making x and y, now it's time to create a training set and testing set. Again, here we are using the same technique to create a training and testing set similarly to the regression approach. So for that, first of all, we have to import the sklearn model selection, and based upon that model selection, we have to import the train, test, and split. So here we have to import train, test, and the last thing that is the split over here. After applying this one, we have to create the x train, x test, y train, and y test. So first of all, we have to write down for the x train, then we have to write down for the x test, then y train and y test. So here I have to take a underscore over here, and after applying all the parameter x train, y test, and x test. So now we have to take on over here the train, test, and split. Here we have to take in this underscore. Yes. Now we have to select the x and y. So here x is already selected, y is already selected, and also we have to provide the test size over here. It means what are the data set, or how many sets you want to take it as a testing size. So now here I want to take a test size is equals to 0.25. So automatically it means training is equals to 75% of data, and testing should be depends upon the 25% of the data. After applying these things, we have to provide the random state over here. So particularly in a random state, we have to take on a 0 over here. Now it's time to run this code, and we are getting still the code was running. We have to check if the code everything is perfect or not. Yes, everything is perfect and code is properly running over here. So in the next things, we have to see about the feature scaling. Now, in the next step, we have to see about the feature scaling. When you are trying to solve the problem based upon the classification approach with the logistic regression or whatever the regression, whatever the classification techniques, at the same time, you have to first of all provide the feature scaling. Feature scaling is always needed when you are trying to solve the problem based upon the classification. But if you can solve the classification problem based upon a decision tree, so at the same time, feature scaling is not required. Otherwise, in other technique like logistic regression, KNN, as well as support vector machine and random forest, many other techniques are always needed the feature scaling. So let's see how to apply a feature scaling in a classification problem. And also we are getting feature scaling idea already in the module number 3 based upon a machine learning part. At the same time, we can learn about the data pre-processing things. So let's see, first of all, import a library based upon the feature scaling. So from sklearn dot pre-processing, so based on sklearn pre-processing, over here we have to import standard scalar. So that's why we have to take standard and then we have to take a scalar. So scalar you have to mention like scalar spelling is the LAR. So after that we have to create over here the shortcut of standard scalar SC. By mistake here we can provide the base. Okay, yes. So SC is equals to, again we have to take standard and again we have to take scalar, standard scalar. Also don't be forgot this blank bracket, otherwise you will get an error. Now we have to apply these standard scaling things on terms of training set. So that's why from the training set we are having two parameter, x train and x test. So let's apply the same thing over here. So x train is equals to sc dot fit underscore transform with the x train. After applying this one, now we have to apply with the x test is equals to sc dot fit underscore transform of x test. So we here we already applied the x train and x test, but here we have to take in the underscore. Yes, now it's complete. So already the standard scalar is applied over here, and in the next step we have to create a logistic regression model, similarly look like the linear regression. So first of all, we have to import a library from the sklearn model. So from sklearn dot linear model, again we are using over here the linear model, and from this linear model we have to import the logistic regression. So we have to import over here the logistic regression. So after applying this one, now we have to try to create a model, and model is equals to, here we have to take in the logistic regression of, also if you don't want to make it random state is equals to 0, so you can also make it a blank as well, as that depends upon you. If you don't want to write anything in between this bracket, basically this type of bracket is used whenever you want to make it some specialized model in terms of some type of the overfitting or some type of the multi-class things, and if you want to provide some type of the value of the class weight, and that's why we are using this type of stuff over here. And after that, now we have to make it model fit with the x train and the y train. So here we have to take an over here the x train, and second parameter is the y train. So the model over here, the model is already prepared over here. In the next things, what we have to do, we have to predict the test results. So we already know once model was prepared over here, then we are trying to make it a y prediction based upon a x test. So for simple code over here are there, y prediction is equals to model dot predict, because we have to prediction, we have to make it some prediction based upon our model. So model dot predict of the x test. X test is already created over here, and based upon that we have to create the y prediction. But when we learn about the theory, learning the theory, at the same time we had seen one thing, that is based upon a confusion matrix. So let's see how we can make it a confusion matrix over here. So for making a confusion matrix, first of all, what we have to do, we have to import one small parameter or one small module based upon a scikit-learn matrices. So we have to use again scikit-learn library over here from sklearn dot matrices import the confusion matrix. Import the confusion matrix over here, and then we have to take an cm is equals to, we already imported over here the confusion matrix. So that's why we have to take a confusion matrix is always created based upon a y test and y prediction, because here we have to find out the true positive, true negative, false positive and false negative, and all the terminologies are coming from the predicted output and the actual output. So that's why we are getting y test as the actual output and y prediction is the prediction output. So that's why these two parameters are very necessary to find out the confusion matrix over here. So here we are getting an idea what are the true positive and what are the true negative and what are the false positive and what are the false negative. So 63 will play as a role of the true positive. So that's how false positive and false negative are there, and also the 25 is the false negative is there. So that's how thing are working over here. Basically the true positive are having the highest number because if the model is tried to predict the actual output is equals to the predicted output. That's why we are getting 63 is equals to true positive. So also here one main thing we have to say about that is the visualizing the training set result, and also we have to visualize the testing set result. But here for visualizing the testing and training set result the code is very lengthy. But before that you have to look at about the how to create a model of the logistic regression. In next session we have to discuss about how to create a training set result based upon the data visualizations. Let's see how to create a visualization to training set results. To making any type of the visualization, first of all, we have to import the library that is based upon a matplotlib. But here we already imported a matplotlib library. But particular when you are trying to visualize the things at the same time, just matplotlib is not enough. Particular from the matplotlib library, there is many more parameter are there. Look like or like a listed color map. So when you want to work with the different type of the color, and also you have to work with particular one type of the grid at the same time, you have to use this listed color map. So from the matplotlib library, so here we have to use matplotlib dot colors library are there, and from this matplotlib dot colors library, I want to import over here that is the listed color map. So that's why we have to import over here the library, and that is the listed color map. Once library was imported, now what is the next step to make it over here? The training set visualization or the testing set visualization is not a simple look like the linear regression. Here we have to create some complicated code as well as, so that's why it's a little bit different as compared to the linear regression training visualizations. So here what we have to first of all make it, first of all here we have to create the x set and y set that is based depends upon the x train and y train. Once we can make it that one part, then also we have to create the things like what are the range for the x-axis and what are the ranges for the y-axis. Also, for example, if I have some points based upon x-axis, like starting point is 1 and ending point that is the 9. So that's why we have to take an the starting point is 0 and the ending point is 10, because the minimum point minus 1 logic we have to use, and also at the last point we have to use maximum point plus 1, that type of logic we have to use. Also in between that we are also trying to provide any type of the step size as well as. After applying these all things, after that we are trying to fit it our parameter into the particular grid, and at the same time we are trying to also make it the linear regression line in between that, and then we can make it a title, x label, y label. And also here we are trying to classify the two classes like class 0 and class 1. And when we are having these two different type of parameters are there, or these two different type of classes are there, so we have to represent both the classes with different color. Also we have to provide the one type of the legend, so legend will show the which color represent the which classes. So this type of things we have to do, and that's why the visualization coding is not easier as easy as to linear regression. Particularly if you are trying to solve the linear regression problem with the visualization, so that looks easy. But if you can do the same thing with the logistic regression, so it's not look easy. So let's see how we can start. So first of all, we have to create the first parameter, that is the x set 1, and the second thing was the x set 2. But you can also take it x set and the y set over here. So x set and y set is equals to, here we have to take an x train and y train. We have to take underscore x train and the y train over here. So after applying x train and y train, the next thing we have to take it a mesh grid, and mesh grid is depends upon the x1 and x2. Once you can provide the x1 and x2, then we have to use numpy function to provide the mesh grid over here. So particularly we should take an np dot mesh grid. Also particularly in that bracket we should take an np dot arrange, because also we have to take in some numbers from according to the our input of x set and y set. So that's why we have to use the arrange function. Particularly in the arrange function we have to provide the start function. So that's why we have to take in start is equals to x set. X set is nothing but a x train. So x train Particularly from the extent, I want to select all the number of rows, and with particular rows, I want to select the zero position of column. After applying zero position of column, we have to take in the minimum number but from that particular column. And once we get the minimum number of that column, also we have to provide the minus one over here. So after applying minus one, we are getting the first of all x-axis starting point according to the legend or according to the particular the x-axis values. Once we can apply the starting point, now in the next we have to apply over here the stopping point. So stop is equals to, again we have to use same logic like x set. Again we have to use all the number of rows, and with particular all the number of rows we have to take on a zero column, it means zero position of column. And now from that column we have to find out the maximum number, and after getting the maximum number we have to take on a plus 1. So after applying plus 1 we have to take a maximum number plus 1 value to stop at the end. So at the same time we are getting some proper graph. Okay, once we are getting the visualization output, then we can also compare the things like what are the importance of these things over here. So after applying this one, next and last thing, that is the step size. So here I want to take the step size is equals to 0.01. So that is again depends upon you. If you want to take it any further things or any different things, you are able to take. Now the comma, because still we are just only provide the one parameter. Now it's time to create the second parameter, in particular that bracket. We can take it some proper arrangement over here like this one, so it looks better for analyze the things. Again we have to take on over here the np dot arrange, and particular in that arrange function again we have to take a start function. So now we have taken start is equals to, in previous one we have to take an x set, again here we have to take an x set over here. So that's why again here I want to take it a x set, so the code is again similarly to look like previous one. Now I want to select the number of rows over here, but in previous one we have to take on a zero position of column, but now I want to take it a one position of column. Why we have to take on one column? Because our classification is predict upon two input variable x1 and x2. X1 will stand on the position of 0 and x2 will stand on the position number 1. That's why. Now after completion of this one, we have to again provide the same coding over here like minimum in bracket we have to take on a minus one, and then we have to provide the stop as well as. So first of all we have to provide the stop, and then we have to take an x set. Again in a square bracket we have to take a number of rows. After applying number of rows we have to take on a zero position, sorry, here we have to take on a one over here, because we are doing everything for the particular first column. And then we have to take on a max of 1 plus 1 we have to take on over here. After applying plus 1, we have to take on a step is equals to 0.01. So again, same step size we have to use over here. And also we have to close over here the bracket. So also we have to check it out all the brackets are closed or not, because here we are using many type of the brackets. That's why we have to careful with that all the brackets. That's why you have to careful with if anyone extra brackets are there, so that will harmful to your code. So now I think everything is looks better, but here there is no required for this bracket because there is extra bracket out there. Because here we are providing the first bracket that will end for this bracket, and also here the start bracket it will end over here, and also this bracket is ended over here. Also we have to check here, so we are applying one more bracket over here, that is not necessary bracket. Now it's perfect, and all the things are looks correctly over here. If you want to run this code you can run, but there is no any guarantee we are getting an output or not. So we are not getting any output because still we have to add many more things. So that's why what we have to do in a next line, we have to trying out what are the model we can create it over here, and we have to fit it that model in with the particular this grades. So that's why we have to use plot function, that is a shortcut of matplotlib, and here we have to use the contour. So contour is a one type of the graph is over here, and we have to take in contour f. So we have to taken some correct spelling of contour, contourf. So down that is the correct, yes. And then particularly we have to take an x1, and second thing that is the x2. X1 and x2 is already created over here, and after applying that we have to take a model dot predict. And after applying model dot predict, again we are trying to create one array based upon a numpy. So that's why we have to take an np dot array. again we have to take in some brackets to apply the ravel of x1 and ravel of x2 to applying any type of the reshape over here. So that's why again we have to take in the square bracket, and particularly with this square bracket we have to use the ravel function x1 of ravel, and second thing that is based upon a x2 of ravel. So you have to careful whenever you are trying to do this type of the problem, because there is many type of brackets are there, and also there is many type of stuff is also there over here. So and then also we have to provide one more bracket over here, and out of the square bracket as well as this bracket, because we have taken many type of bracket over here, so please don't be confused during this one. And also we have to provide over here the transpose as well as. So after applying a transpose, again we are trying to use a reshape function to arrange the things particular with the input of x1 shape. So that's why here again we have to take in one bracket, and with that bracket we have to provide x1 dot shape. After applying this shape, next things we have to provide the size of the particular circle or the scatter plot, because here first of all we have to import it all the samples from the training set and testing training set, we have to import it over here. So we have to select the size of the particular sample, like in terms of the dot points, or the when we are taking some large size at the same time large circle we are getting, but if we are taking the small circle, so at the same time the sizes matter very well. So here we have to select the size, and the size that is the sizes depends upon the alpha. So alpha is equals to, I want to take it over here, the 0.75. So 0.75 that is the alpha, and we have to take on a C map. So C map is equals to, we have to take on over here the again according to the our listed color map. I want to select over here the C map or the color map, and now we have to decide the color for particular that one. So the color to provide over here that one, that is the red and green. So first color is the red, and second color that is the green. So after applying, if you can see the three brackets are over here. Now I'm trying to do this code, and you are getting this one still now. So till now we are just only able to create this one. So we are getting an idea. One region will be shown as a red color, and the second region will be shown as a green color. And now if you can see, so we are taken this -1 and +1 for according to this one. Basically our all the samples are are running in between -2 to +2, but still here we are taken 0 over here, and also here we are taken up to 3 over here. So that's how the +1 difference we are getting over here. Similarly also over here, here the minimum value is around -3, so our sample is always considered in between -1.5 to +2.5. So that type of stuff we are getting over here. So still we have to be make it some more change over here, based upon that particular limit over here. So now we have to decide the plot of the x limit and y limit. So first of all, I'm trying to do with the x limit, and in x limit we have to take on a number of x1 dot minimum. So now we are to doing what are the things, that is everything is based upon our data set. So here I have to select the x1 dot minimum, and now we have to take an x1 dot maximum over here. And after applying this one, now we have to take a plot dot ylim of x2 minimum, because first parameter based upon that we already taken, and second parameter is look related to the x2, and now we have to take an x2 dot max. So now again I'm trying to run this code, and let's see what are the output we are getting over here. The sum of type of the number we are getting over here, like -2.58 and also 3.32. Let's add some more things based upon that, and now we have to add last thing, but very very important thing according to the our data set, or based upon also the model. So here I am trying to provide one for loop, and the loop is related to for I and j, particularly I and j in enumerate function I want to use. We already learned about the for loop and enumerate in Python lectures. So for enumerate, and now I want to find out some unique things from the NumPy library. So that's why I have to use np.unique of y set. So from the y set, it means from the y train, I want to find out some unique samples. So that's why I have to use y test. And also we have to provide the semicolon to follow the proper indentations. And based upon that, now internal to this one, I want to make it a scatter plot based upon the x train. That's why I have to use x set over here. After applying x set, also in a square bracket, I have to take it y set is equals to the j, and the particular we have to provide the some condition like j and the 0. And after that, also we have to provide the x train limitations, like x set is equals to x set of, we have to take an y set, and then we have to take an is equals to j, and particular for the 1. So 0 and 1 is stand for the 0 position of column and the 1 position of column. So after applying this one, now we have to take another value of c over here. So the c is equals to, it depends upon the color, so listed color map we have to take on over here. So particularly here we have to take on a capital C, because spelling mistake are created very big issues during this type of stuff. So here we have to decide the things. One type of sample is related to the red color, and second type of samples is related to the green color. So that's why again we are taking over here. So here we are providing color two times. First of all, we have to provide the color for the outer side region, and second time we have to provide color for the inner side region. So after applying red and green color, in the last we have to just simply take off some type of this samples over here. And after applying sample over here, we have to take a label is equals to j. So all the most important and main necessary thing is already completed till now, but still we are trying to run this code. Let's check it out, any type of the error we are getting over here or not. Here we have to take an double is equals to, yes. So that is the first output is there, but still here the some type of things we all still missed it. So let's complete first of all that one. But here you are getting an idea. So all the samples are coming in between -2 to +2.3. So that's why here we are taken last limit, that is a 3.3, and here the last limit is this -3. Also from here you will get an idea, in this area there is no one plots and no one samples are there. That's why if I can make it +1 in compared to if I can make it +2 at the same time, the grid will look very large. So that is the advantage of to write down these whole things together. Still the code was not over, because still I want to provide over here the title, legends, and as well as the x label and y label. So let's provide the title of particularly that one. In testing set we are using the same code, but as a replacement of that we have to change some parameter. But before that, let's apply the plot dot title, and internally title we have to provide logistic regression training set. So after applying that one, the next thing, that is the plot dot x label. Particularly in the bracket we have to take on as the age in a x parameter, or and also in a y label we have to take on over here the estimated salary. So both the thing was completed over here, and last we have to use the plot dot legend. So legend is very important function over here. So with the help of the legend, we have to check if the spelling of legend, Legend, that is correct. And at the end we have to provide the plot dot show. So we are getting an output very good and very correctly. So if you're getting an idea, with the help of the legend things we are getting this one, there is a logistic, we are getting the logistic. Otherwise the remaining thing was correct. Yes, now it's correct. Logistic regression training said in a y-axis we are getting the estimated salary, in a x-axis we are getting the age. So that's how things are working in particular for the training set. Now we are trying to make it the same thing for the testing set as well. As to applying the testing set, we are not writing any type of the new code, we are just copy and paste this code, but we have to change some parameter things, so we can change that parameter, because now you already know how to apply these things particular for the testing set. So in a testing set we have to replace x train and y train with the x test and the y test, but the structure of code is looks very similarly to the training set as well. As so in a second things we are taken 0 and 1, so that is no need to apply any type of changing over here. Just we have to apply that type of change, that is depends upon the x train and y train, so automatically x set and y set is replaced to everywhere. And now we are trying to run this code, but still before that we have to check it out, is there any other places are there where I can use the training set or the x train type of the function. So let's run the same thing, and now we are getting idea with the 25 percentage of the data. This sample is related to the 75 percentage of the data, because that is the training set result, and these are the testing set results. So that's why we are getting samples related to just only the 25 percentage. And based upon the lesion we are getting over here the things like a red sample related to the class 0, and the green sample that is related to the class number 1. So that's how we are able to do the logistic regression with the particularly matplotlib library for basically to do the data visualization. And with the scikit-learn, we are able to do the same thing for the making the model. In the next things, we have to see about the k nearest neighbor. K nearest neighbor is a very easiest method. First of all, we should learn about that theory, and then we can jump on the practical of the k nearest neighbor. Let's talk about the objective of logistic regression. Logistic regression work for both, but it is much popular for binary classification. So let's see what are the things related to the binary classification. Given the subject and the email text predicting email spam or not, sunny or rainy day prediction using the weather information, and based on the bank customer history predicting whether to give the loan or not. So they are also working based upon some independent feature like inputs. So based upon inputs, the bank will get an idea like they can issue the loan or not. But then we have to concern upon a logistic regression. So logistic regression are much popular for the binary classification due to the sigmoid probability or the sigmoid function. So that's why logistic regression is not much popular for the multi-class classification. But now we have to see about like what are the cases are available with the multi-class classification. So with the multi-class classification, like given the dimensional information of the object, like identifying the shape of the object, identifying the different kind of vehicles, identifying the different kind of animals, as well as based on the color intensities, predicting the color type as well. So that type of stuff we are getting from the multi-class classification. But if you want to do multi-class classification, so at the same time, like decision tree, support vector machine, random forest, then many more techniques are available to do multi-class classification. But for binary classification, logistic regression can provide the good output as well as. So now let's check it out how to do model evaluation with the confusion matrix, because confusion matrix is again and again it's a very important part over there in the classification algorithm. Whenever you are working with the classification algorithm, if you want to evaluate your models, at the same time you have to develop or you have to create a confusion matrix. So what is a confusion matrix? A confusion matrix is a table that is often used to describe the performance of a classification model or a classifier on a set of test data for which the true values are known. So, the confusion matrix itself is relatively simple to understand, but the related to the terminology can be confusing. So based upon confusion matrix, in my mind, again question will rise, that is how to calculate confusion matrix. How we are able to calculate the confusion matrix. That is again and again important thing are there. So you need to take a test data set or a validation data set with expected outcome values and make a prediction for each row in your test data set. From the expected outcomes or the prediction count, the number of correct prediction for each classes should be generated over there. And after understand of the confusion matrix, let's check it out. What is the representation of other terms? So basically, in the confusion matrix should be built based upon a TP, FP, FN, and TN. So what is the meaning behind all these things? So TP stand for the true positive, FP stand for the false positive, FN stand for the false negative, and TN stand for the true negative. So let's start it with the first thing, and that is the true positive. It means it should become look like correctly identified. So a true positive is an outcome where the model correctly predicts the positive class. Similarly, a true negative is an outcome where the model correctly predicts the negative class. A false positive is an outcome where the model incorrectly predicts the positive class. So true positive, it should stand for the sick people correctly identified as a sick, like class 1 it comes in a class 1. So expected and the predicted, expected and actual both are equal. After true positive, second thing, that is the FP, false positive, that is also understood by incorrectly identified. A false positive is usually called as a type 1 error, and a type 1 error is when you incorrectly reject the null hypothesis, and this creates a false positive for your research, leading you to believe that your hypothesis is true when in fact is not. So false positive, it should also take an example like healthy people incorrectly identify as sick. So class 0, it should represent as a class 1. So that's why its mistake should done over here. Next thing, that is the true negative, it is the correctly rejected thing is there. So here a true positive is an outcome where the model correctly predicts the positive class. Similarly, a true negative is an outcome where the model correctly predicts the negative class. A false positive is an outcome where the model incorrectly predicts the positive class. And true negative will take an example like healthy people correctly identified as healthy. Class 0 is identified as a class 0. So that type of thing we are getting from the true negative. After true negative, the last thing based upon a confusion matrix, that is the false negative. False negative understand as a incorrectly rejected. A false negative error or a false negative things is a test result which wrongly indicates that a condition does not hold. For example, when a pregnancy test indicates a woman is not pregnant but she is, or when a person guilty of crime is acquitted, these are false negative. So false negative can come with the example like sick people incorrectly identify as healthy. So class 0 by default identify as class 1. So that type of thing can generate during the confusion matrix in the model evaluation. But among these confusion matrix, still there is some of things are available to do evaluation, and that is the precision or recall trade-off. So what is meaning behind the precision and recall? Let's talk about that one. Like, what is recall? Recall is the number of relevant documents retrieved by a search divided by the total number of existing relevant documents, while precision is the number of relevant documents retrieved by a search divided by the total number of documents retrieved by that search. To detect age appropriate videos for kids, you need high precision or low recall to ensure that only safe videos make the cut, even though a few safe videos may be left out as well. As to detect age appropriate videos for your kids, you have to go with the high precision and low recall. That is the important part over here, and you have to follow that one. That's why precision and recall trade-off, it is important thing over here. So after getting about almost everything related to the logistic regression or the classification things, now let's talk about some of the classification based application or the use case. Like if you want to find whether an email received is spam or harm, like not spam, so this application is based upon a logistic regression and support vector machine. If you want to identify the customer segments, like customer coming which from which segment in e-commerce thing, also in banking sector to find a bank loan is granted or not, or in this particular school to identify if a kid will pass or fail in examination. So that type of thing, if you want to find. So at the same time, logistic regression should be the good thing are there. And in the last, we have to take one use cases based upon a spam filter. The idea of this post is related to spam filters, understand step by step working of spam filter and how it helps in making everyone life easier. Also, next time when you can see you have won a lottery email, rather than ignoring it, you might prefer to report as spam. So also whenever we are working, we are having email IDs is there or Gmail IDs there. So during that daily you are getting the messages like your loan is granted, you are getting these lotteries are there, you are getting these benefits, this and this, so all are the spam are there. If you can consider these mails as spam, so from next time you are not getting that type of mails. So spam filtering is a beginner example of the document classification task, which involves the classifying an email as a spam or not spam. And spam box in your Gmail account is the best example of this one. So that's how you are getting idea like how the spam filter can build based upon a logistic regression, when it should be worked within spam or not spam. So again, this particular session is completed over here, and from the next session, we have to learn about the basic idea about the unsupervised learning. Now we are going to start this session with the unsupervised learning case study. So what is the meaning behind the unsupervised learning, and as well as that thing we can see in this session later. But first of all, we can take one small case study based upon that. Ever wondered how NASA discovered a new heavenly body and identifies that is different from a previously known astronomical object, or it has no knowledge about these new bodies but classifies them into proper categories? So that type of thing should raise in unsupervised learning. So NASA uses unsupervised learning to create a cluster of heavenly bodies, with each cluster containing objects of a similar nature. So whenever the cluster are not defined or not identified, but it looks small, small or large, large, so they can make in some cluster based upon small objects or the large objects. So let's find out the definition of unsupervised learning to get some better idea about the same thing. Unsupervised learning is a type of machine learning algorithm used to draw the inference from dataset consisting of input data without labeled response. The most common unsupervised learning method is cluster analysis, which is used for exploratory data analysis to find hidden patterns or grouping in data. In other words, the unsupervised learning is a subset of machine learning used to extract inference from dataset that consist of input data without labeled response. So after getting idea about the unsupervised learning, let's find out what are the types of unsupervised learning. Basically, three types of unsupervised learning is there. First is the clustering, second is the visualization algorithm, and third one is the anomaly detection. Of among these three types, the clustering is very popular technique from the unsupervised learning. So let's talk about one of the overview related things based upon k-means algorithm or the k-means clustering. Clustering is the task of dividing the population or data points into a number of groups such that data points in the same group are more similarly to other data points in the same group than those in other groups. In simple words, the aim is to segregate groups with similar traits and assign them into cluster. The most common unsupervised learning method is cluster analysis, and it is used to find data clusters so that each cluster has the most closely matched data. For example, an online news portal, segments, articles, and many more things are there that can consider within a clustering. Because whenever we are working, we are seeing some online news or online news applications. At the same time, different type of sections is there, like world-based thing are there, business, technology, entertainment, sports, finance, science, health. Many more type of categories are there. So that all thing can based upon a clustering or Clemens clustering. So again, this session is a it's very small session is there based upon a unsupervised learning. But from next session, we can also take in some more idea about this type of small terminology in the machine learning ideas or the machine learning types. Let's start with the last part of this session, and that is semi-supervised learning and the reinforcement learning. And in the last, we can take in some idea about some important reconsideration in a machine learning. So let's start it with the first thing, and that is the semi-supervised learning. So what is semi-supervised learning? It is a hybrid approach, and it is also understood as a combination of supervised learning and unsupervised learning with some labeled data set and some non-labeled data set. So whenever we are having labeled, non-labeled, and the combination of supervised and unsupervised, it is known as a semi-supervised learning. Also, let's check it out some of the example based upon a semi-supervised learning. So you will get a better idea about semi-supervised algorithms. First thing, that is the Google Photos automatically detects the same person in multiple photos from a vacation trip. So that is based upon a clustering or unsupervised. But one has to just name the person once, like supervised, and the name tag gets attached to that person in all photos. For example, I have 10 photos is there. In one photo, I just provide my name. That is my name is this one. The person A is my name, so according to that it can correlate it with all the photos, but in other photos I cannot attach my name, but still in one photo is similarly to another 9 photos, and in one photos I already provided my name, so it's auto correlated to all the photos. So that's type of thing should working in example of semi supervised learning algorithms. After semi-supervised learning, let's talk about some of the thing in reinforcement learning. Here we are not spending lots of time based upon a reinforcement learning because one of the whole module is represented with the reinforcement learning. So at the same time, we can spend more time based upon a reinforcement learning. Still, here we are just only getting some basic idea about the reinforcement learning. Reinforcement learning is a type of machine learning that allows the learning system to observe the environment and learn the ideal behavior based on trying to maximize some notion of the cumulative reward. So that's how, based upon a feedback and reward, the reinforcement learning should be work. Let's talk about some of the features of the reinforcement learning. The learning system, like agent, observe the environment, select and take certain actions, and gets reward in return. The agent learns the strategy or policy that maximize its rewards over the time. In a manufacturing unit, a robot uses deep reinforcement learning to identify a device from one box and put it in a container. and the robot learns this by means of reward-based learning system and which intensives it for the right action. So that's how we are getting some idea about how feature of reinforcement learning should be worked in this over here. So after discussion of features of reinforcement learning, let's talk about some of the example. We already discussed about this example during the features like how the robotics should work based upon this type of reinforcement learning. Like KUKA robotics are good with the machine learning and as well as some robotics knowledge as well as. So that's how if they both combine, so there's a good product for the reinforcement learning. Now we have to talk about some of the important consideration for the machine learning technique, and that is based upon a bias and variance trade-off. Bias refers to error in the machine learning model due to wrong assumptions. A high bias model will underfit the training data. Variance refers to problem caused due to the overfitting, and this is result of oversensitivity of the model to small variations in the training data. A model with many degrees of freedom, such as high degree polynomial model, is likely to have a high variance and thus overfit the training data. So similarly, the bias is simplifying assumptions made by the model to make the target function easier to approximate, and variance is the amount that the estimate of the target function will change given different training data. So trade-off is tension between the error introduced by the bias and the variance. So that's how thinking are working over here. So that's why we can also evaluate the thing based upon a bias and variance dependencies. So increasing a model complexity will reduce its bias and increase its variance. Conversely, reducing a model's complexity will increase its bias and reduce its variance. This is why it is called a trade-off. A linear machine learning algorithm will exhibit high bias but low variance. On the other hand, a nonlinear algorithm will exhibit low bias but high variance. Using a linear model with a data set that is nonlinear will introduce bias into the model. So that's why bias and variance both are having their own independence and own importance in the particular machine learning model. So after discussion about the same consideration, in the end of this session, we have to talk about representation learning. So in machine learning, representation refers the way of the data is presented, and this often make a huge difference in understanding. So the representation learning are not the actual world in terms of the algorithm. This is just only for information. I can provide you the thinking behind the representation learning. So basically, in this whole module of machine learning type, we have to explore about the supervised learning, unsupervised learning, reinforcement learning, semi-supervised learning, and then representation learning. Whereas we have to briefly discuss about the linear regression and the logistic regression. Thank you guys. Till then, enjoy machine learning with Python.